I'm Anil Kumar. Welcome to my series on limits. We are taking some challenging questions which will help many students get admission to excellent universities. Here is a question which is to evaluate limit when x approaches infinity for square root of x square minus x. Now we are not only going to solve this question, but we learn techniques to solve. So one method to solve this will be rationalization. And the other will be binomial series. Now this is relatively a simple question to take, and therefore it can be actually solved by rationalization also. At times you might get very difficult questions where binomial series will be much better option. Now if I substitute infinity for x, I get a form which is infinity minus infinity. So it is indeterminate form. So for any indeterminate form, you could use some techniques and then find a limit. So limit might exist. That's the whole idea. So let's do rationalization and find limit. So we have limit x approaches infinity, square root of x square minus x. To rationalize, I have to multiply and divide by its conjugate. So we get square root of x square minus x plus x over square root of x square minus x plus x. So that is equal to limit x approaches infinity, a square minus b square, which is x square minus x square, divided by all this, which is square root of x square minus x plus x, right? Now the numerator can be simplified. We get limit x approaches infinity minus x over. Now when you land up with such situation, we need to factor out this x square. So what we get here is, if I factor out x square, I get 1 minus 1 over x, and here we have plus x. Now as x is approaching positive infinity, square root of x squared is x. So I could write this as limit x approaches infinity. We have minus x on the top, x times 1 minus 1 over x within square root plus x. Correct? Now when x is approaching very large number, 1 over x will approach 0, right? So this will approach 0, and therefore we can also cancel this. So what do we get? We could write this as limit x approaches infinity for minus 1 over square root of 1. Before cancelling, I should have taken it a common factor. Let me cancel this also, right? So plus 1. So let me extend one more step here. So let me write here limit x approaches infinity. Just to make it very clear, what we get here is x is a common factor. We get square root of 1 minus 1 over x, right? Plus 1, correct? Now you cancel x, right? So when you cancel at that stage, you have to cancel this also. So when you think about it, when x is approaching infinity, then all this is equal to minus 1 over x, since 1 over x approaches 0, right? So what do we get here is basically equal to minus 1 over 2. So the limit of this function is minus 1 over 2. So we could easily solve this particular question using rationalization. Now let us again solve this using the second method, which is binomial series. The binomial series, as some of you might know, could be extended for exponents which are not whole numbers, right? Which are rational numbers. So we could write 1 plus x to the power of n as equal to 1 plus nx plus n times n minus 1 over 2 factorial x square plus n times n minus 1 times n minus 2 over 3 factorial times x cube, and so on, right? I'll provide you a link, rather at the end of this video, I'll attach explanation to this, right? So that it's not so difficult for you to understand. But the important thing here is that the absolute value of x should be less than 1. That is kind of very important to use this formula. So now we are going to use this formula to find the limit, and it is a standard formula which Newton derived using the expansion, binomial expansion and Maclaurin series, right? So we are not getting into that derivation, but we'll take it as such. So now, if you have to solve such a question, you really have to expand this particular part. Now, as you see, we would like to have a form which is 1 plus x, where x is less than 1, right? So what you could do here is that you could factor out x squared, right, in this expansion. So what we have here, so we have square root of, if I take away x squared, then I get 1 minus 1 over x, correct? Within the square root, and here we have x. Perfect. So we do have a form which is similar to what we were working with. So I could write this as limit x approaches infinity, and since x is approaching positive infinity, square root of x squared, which is absolute x, now can be written as x, right? Square root of 1 minus 1 over x minus x. So here the power is half. Do you see that? So here the power is half. So the value of n is half. Let me rewrite this. So we have limit x approaches infinity, and we have x times 1 minus 1 over x to the power of half minus x. So what do you notice that in our case, 1 over x, since x is approaching infinity, 1 over x approaches 0, right? So in our case, 1 over x is approaching 0, much lesser than 1, correct? And the power exponent n is half. So we're going to use this formula with n as half and expand, right? So we get the first term, which is x times 1. Now since this value here is minus 1 over x, so I'll write minus, n is half, right? So minus half, and then times 1 over x, correct? So that is our first term. Plus, now the x squared means we'll make it positive, so I'll get plus here. N is half for us, so we'll write half minus 1 over 2 factorial, which is 2, right? X squared means 1 over x squared for us, right? Plus so on. And then we have at the end minus x. Do you see that part, right? Now, as we go further, since x approaches infinity, we'll have higher powers of x, so 1 over x squared will be 0. That's why we're not writing those. Clear? So we get here limit x approaches infinity. So if we expand this, we get x minus half, and then this term will approach 0, right? So this term will also, because x is here, so it is something over x, right? So you could write here as plus, now when you open this, half minus 1 is minus half. So you get 1 over 8 minus 1 over 8x, correct? When you multiply, this will be like this. And plus so on. I'm not writing other terms, because then the power of in the denominator will be x squared minus x. So here, plus x and minus x cancel. When x is approaching infinity, this approaches 0, right? So this term approaches 0. So what are you left with? You're only left with minus half. You get minus half as your answer. You get the idea. So using this series, just writing the first 2-3 terms, we get our answer very fast. So that is how you could do it. So I hope you see a clear advantage of binomial series being used. So in the next example, you will find how powerful this particular application is to solve difficult questions. I've taken up a very difficult question here, which can be solved using some advanced calculus strategies. Now, these types of questions can help you in the entrance exams for good institutes. The question here is also picked from one of such institute. It is limit x approaches infinity for square root of x squared minus 4x minus ax minus b equals to 7, then find value of a and b. You can always pause the video, answer the question, and then look into my suggestions. Now, to solve such questions, we might take help of binomial series. So let me first explain what binomial series is, and then we are going to apply this strategy. So you know about the binomial expansion, which is a plus b to the power of n is equals to nc0 a to the power of n plus nc1 a n minus 1 b plus nc2 a n minus 1 times b square, and so on. Here, the exponents n and r are whole numbers, non-negative integers. The binomial coefficient NCR is n factorial over n minus r factorial times r factorial, right? So we should write few terms here which are going to help us. NC0 is going to be 1, NC1 is going to be n, NC2 is going to n minus 2 will give you two terms in the numerator, which will be n times n minus 1. The rest will cancel, right? And r factorial will give you 2 factorial here. Do you see that? So NC2 will be this. And for NC3, let's rewrite. NC3 will have 3 terms multiplied here, n times n minus 1 times n minus 2 divided by 3 factorial. So that is how these binomial coefficients could be calculated and placed in this particular series, right? So that is just a refresh on what this binomial expansion is. Now let's take few important examples here, especially the case when a equals to 1, right? In that case, we get 1 plus b to the power of n, correct? So now of b, right? And we'll have nc0, which is basically 1, plus nc1b plus nc2b square, so on, right? So ncr, b to the power of r, ncn, b to the power of n, correct? So the series will now get converted like this. Now this is extremely important series which we are going to use many times to find limits. Now Newton actually utilized this binomial theorem. This is actually expansion of binomial theorem. So Newton actually used this series in a very different way. He kind of extended this series so that we could use it even when n is not a whole number, right? That's the whole idea, right? So that's what he did, and he took help of Maclaurin series, right? So that was the addition to this, and then utilize this series so that we could actually use the same expansion with rational exponents. That's the whole idea, right? So in that case, I'll just give you the result, which is very important for us to take while we solve our questions, right? So if I have 1 plus x to the power of n, right, and in this particular case, the value of x extended for, let me write here, expanded for this value of absolute value of x less than 1, a very special case, right? So in that case, 1 plus x to the power of n could be written as 1 plus the same formula. What I'm trying to say, exactly the same formula. However, you can use n as a rational number. That's very important, right? So we'll write this as nx plus n times n minus 1 over 2 factorial x square plus n times n minus 1 times n minus 2 over 3 factorial x cube, and so on. You get an idea, right? So that is the use which, that is the extension which we are going to use in most of the cases where limits is very difficult to find. And you will soon learn that whenever we have a limit which will be of the type infinity minus infinity, there is an indeterminate. We'll use this particular series to solve. Perfect. So with that, let's now solve our question. Okay, so a brief introduction of binomial series will really help us to solve this particular limit. So the question for us is, if limit x approaches infinity for square root of x squared minus 4x minus ax minus b equals to 7, then find the value of a and b. As you can see, it is of the form infinity minus infinity, right? So that is the form. So it is an indeterminate which can have a limit. We are given limit of 7. Now we need to find what a and b is. So our strategy here is to use binomial series. So what we are going to do here is we'll make a small substitution. We'll say let x equals to 1 over t. So when x approaches, in this case, infinity, then t should approach 0, right? So 1 over 0 is infinity. So what we get here is limit t approaches 0 for 1 over t square minus 4 over t square root minus a over t minus b. Now this limit is given to us as equal to 7, right? This is given to us as equal to 7. Now let's simplify this. So we get limit t approaches 0 square root of, so t square is common term, so we get t minus, 1 minus 4t, right? 1 minus 4t over t square within square root. And here we have a term which is minus, I can take t common here also, right? So that gives me a plus bt, right? Equals to 7. Now here t square within square root can be taken outside, so we get limit t approaches 0, and we could write this as square root of 1 minus 4t minus a minus bt. So we are just taking t common, right? Over t, correct? So taking this out, we can take common t, and then we get this equals to 7. Now, as you can see, t is approaching 0, right? So since t is approaching 0, 4t is actually less than 1, correct? 4t is less than 1, and therefore it is actually approaching 0, right? Now, since it is approaching 0, and that too from positive side, square root will be from positive side, we can use the binomial series, right? That's the whole idea. So the binomial expansion, which we just learned, which we can utilize, let me rewrite here, is 1 plus x to the power of n is equal to 1 plus nx plus n times n minus 1 over 2 x squared plus n times n minus 1 times n minus 2 over This is actually 2 factorial, 3 factorial, right? Times x square plus so on, correct? So that is the expansion, the binomial series, which we are going to use here. So the term here, as you can see, is basically, instead of x, we have 4t here, right? So that's what we have. So if you expand this, what do you get? So we get limit t approaches 0. So this is to the power of half. So let me rewrite this first, and then we'll expand it in the next statement. So we have here t, and I could write this as 1 minus 4t to the power of half, right? And we have the term minus a minus bt. As you see, in this case, 4t is basically much less than 0. It approaches, much less than 1, it approaches 0. Now we'll apply this expansion here, right? So we know all this is equal to 7. So let me write 7 here. So 7 is equal to limit t approaches 0. So when you expand, the first term is 1. Now in this case, we have minus 4t, right? So all the terms where x is odd power will be negative, and terms where x is positive power will be positive, right? Minus 4t, we have to substitute for x, correct? In this formula, n is equals to half, right? So that's what we'll do. So what we get here is 1 minus, so half times, I should have written half first, half times minus 4t, right? So half times 4t, correct? So that is your first term, minus I wrote earlier, right? Then when this is a positive power, it will be positive here, n is half. So half times half minus 1 over 2 factorial, which is 2, right? 2 factorial. Or you can write 2 factorial. And x square means 4t square, right? So that is the square. So we'll write this as 4t whole square minus, because the next term is cube, so that will give you minus, so on. I'm not writing the other terms since t is approaching 0, and for higher powers of t, those terms will be approaching 0, correct? Okay, and then we have this term here, minus a minus bt. So we have minus a minus bt, correct? And all this is multiplied by 1 over t, correct? So that is what you have. Now if you look at it, when you multiply everything by 1 over t, so at this stage you will get, this will be so let's just expand this, right? So what we get here is 7 equals to limit t approaches 0. So when you multiply here, the first term is minus 1. So minus 1 divided by t, so let's rewrite this. So we have 1 here, and in this case we get minus 2t, right? So we get minus 2t. Here it is half minus 1 is minus 1, right? So this term, basically you find that this term will be having a coefficient of t. So when you divide, that will be going to 0, right? So this term will be, you can write this as half, you can write 1 over 8 with a negative term. We'll just keep it like this. Over 2 and 16 t square, okay. Minus so on. All these terms will be actually 0. And here we have minus a, and then we have minus bt. Everything is divided, by t. So in this particular expression, when t is approaching 0, higher powers of t, will be approaching 0. So this will approach to 0, right? All the terms after this will also approach to 0. So what are you left with? So if you analyze this, you are left with 1 minus a, and with t, you are left with minus 2t minus bt, correct? So that is what we are left with. So you could write this as limit t approaches 0, 1 minus a, right? That is one term which is left. And then if you take minus common, we have 2t plus bt, right? These are the t terms left over t. That is what is left with us. Now if this has to have a limit, right? So in that case, 1 minus a should be equal to 0. Correct? So if this has to have a limit, so in that case, 1 minus a should be 0. So let me rewrite this as 7 equals to limit t approaches 0. So the first term is 1 minus a over t. The other term, I could write this as minus t and t cancel, or you can say t common, 2 plus b, right, over t, right. Now to have a limit in this particular case, 1 minus a should be equal to 0, right? So this implies that 1 minus a should be equal to 0, which gives you a as equal to 1, correct? So a should be equal to 0. So a should be equal to 1, right? Now the second part here is 7 is equal, but it has a limit of 7. So when a is equal to 1, we get 7 equals to minus 2 plus b, right? Because this t and t will cancel, so 7 is basically equal to minus 2 plus b. So solving this, we get minus 7 equals to 2 plus b, or b equals to minus 7 minus 2, which is minus 9, right? So we get the value of b as minus 9. Is that clear? So the two values will be a equals to 1 and b equals to minus 9. Perfect. So that is how you're going to solve this particular question. Now let's get back to some intricacies involved here. Now these questions, which are of the form infinity minus infinity, could be solved using binomial series, which is here. Now in this series, since we are dividing by t, right, all the terms with t square and higher powers will be neglected since t approaches 0. That's why we didn't really work on this, and the later terms we omitted since they will be 0, right? Now, for the limit to exist, we had the term 1 minus a over t, where t approaches 0. So 1 minus a should be 0, otherwise the limit will not exist. So that gave us one equation, and from there we calculated a as 1. Now if a is 1, the first term is 0. We are left with t times 2 plus b with a negative sign. T and t cancels. So we are left with 2 plus b with a negative sign. And that should be equal to 7. So we got our equation minus 7 equals to 2 plus b, solving which we get b equals to minus 9. Perfect. So that is how you're going to solve it. So I hope that makes sense. Feel free to write your comments and share your views. If you like, and subscribe to my videos, that would be great. Thanks for watching and all the best.